Let's talk about tap water. In researching tap water and what's contained in tap water in different regions, not just in the US, but around the world, I confess the picture is a pretty scary one. I want to be clear, I'm not somebody who naturally orients towards fear or conspiracy theories. However, in researching tap water for this episode, by way of looking at the peer-reviewed research, meta-analyses, reviews, specific research articles where specific hypotheses were tested, and in talking with experts in toxicology and so on, it's a pretty grim picture, frankly, when one looks at what's contained in most tap water and whether or not the compounds that are contained in tap water are present in sufficient concentrations to negatively impact our health. And the bad news is that much, if not all tap water, believe it or not, much, if not all tap water contains things that are bad for the biology of our cells. There is a silver lining, however, and the silver lining is that very simple steps that are very inexpensive can be used to adjust that tap water to make it not just safe to drink, but that makes it perfectly fine to drink. So that's the good news, and we'll get to that in a moment. If you are somebody who is interested in whether or not tap water contains things like endocrine disruptors, hormone disruptors that can negatively impact reproductive health in males or females or both, there's a wonderful review, wonderful because it's so thorough, although the news isn't great, it's very thorough, which is great, which is entitled Endocrine Disruptors in Water and Their Effects on the Reproductive System. This is a review from 2020 that analyzes water from a bunch of different sources within the world and essentially focuses on a few key components. First of all, it focuses on the concentration of minerals, that is magnesium and calcium within water. Many people don't realize this, but so-called hard water sounds terrible, right? But hard water is water that contains magnesium and calcium, which turns out to be a good thing. Some water contains more magnesium and calcium. Other water contains less. They looked at the presence of magnesium and calcium because that is going to impact the pH of water. In general, the higher concentrations of magnesium and calcium in water, the higher the pH. That is, the more alkaline that water is, and the lower levels of magnesium and calcium, the more acidic or lower pH that water tends to be. The other thing that this review addresses is the concentration of so-called DBPs, dog, bulldog, porcupines, DBPs, which are disinfection byproducts contained in water. So obviously local governments, the government wants your drinking water to be clean. They don't want contaminants in it. They don't want sewage in that water. They don't want chemical contaminants that are going to make people immediately sick. So they treat water treatment plants treat water with disinfection products, and those disinfection products create things called disinfection byproducts. And the presence of those DBPs or disinfectant byproducts can strongly impact the pH of water by way of changing the concentrations of magnesium and calcium. Put differently, I do believe that governments are trying to provide people with clean water, but in doing so, oftentimes will introduce things to that water that are not good for us. Now, it's very clear that DBPs can cause endocrine disruption in ways that are not good for reproductive health. I did a very long, in fact, 4.5-hour episode on fertility and vitality. That was male and female fertility, by the way, and vitality. That, again, you can find at hubermanlab.com, that talks about all the biological processes involved in the generation of healthy eggs and sperm and creating healthy embryos, implantation of embryos, and so forth. It's very clear that DBPs have been shown to disrupt ovarian function, spermatogenesis, and fertility outcomes, even at concentrations of DBPs that are present in drinking water that comes from the tap. Now, does that mean that you shouldn't drink tap water? Well, the answer to that is it depends. What does it depend on? Well, it depends on several things. First of all, I highly recommend that everybody go online and put in your zip code and ask for a water analysis of water that comes out of the tap in that zip code. This is something that is readily available online, at least to my knowledge, and unfortunately, there's no specific one site that I can send everyone to get an in-depth analysis of the drinking water that comes out of your tap. However, I highly recommend that you go online and put in your zip code or municipal area code and figure out whether or not your water contains X amount of DBPs or Y amount of DBPs. Now, of course, you're going to get a bunch of values back, and unless you're a toxicologist, you're probably not going to know what those values mean. But what you're really looking for is whether or not there are high, low, or moderate levels of fluoride in that drinking water. Why do I say that? Well, there are studies that show that the concentration of fluoride in drinking water is of particular concern for the thyroid hormone system of the body. Now, thyroid hormone has a lot of different roles in brain and body, and thyroid hormone is very important for everything from metabolism to levels of energy. When thyroid levels are disrupted or if thyroid receptors are disrupted, it can lead to depression. When thyroid hormones are optimized, it can lead to optimal mood, if there is such a thing, but in other words, it helps keep your mood elevated. It relates to everything from sleep to reproduction. Thyroid hormone is involved in many, many things, including bone health and tissue health generally. So essentially every biological process in your body is impacted by thyroid hormone. And there's a study that I'd like to highlight, which was published in 2018. And the title of the study is Impact of Drinking Water Fluoride on Human Thyroid Hormones. This was a case control study, so this is not an extensive analysis of many individuals. However, what it shows is that fluoride negatively impacts thyroid stimulating hormone and so-called T3 levels. So you have thyroid hormone T3 and T4. Even in the standard concentrations that are present of, and here's an important number, 0.5 milligrams per liter. Okay, so if you can get a hold of the fluoride concentrations in your tap water and find out whether or not the concentrations are at, below, or exceed 0.5 milligrams per liter, what you will find is that even just 0.5 milligrams per liter of water can disrupt thyroid function. And this is going to be a particular concern for people that have familial, so genetically related thyroid issues, or that are concerned with keeping your thyroid hormone levels healthy, which I think is everybody. So I am telling you that you should try and get a hold of some data about the water that comes out of your tap if you intend on drinking tap water. And probably even if you don't, you should just know what's in your drinking water. Your local government should provide that information, and or it should be readily available online. And in particular, I think it's worthwhile to address how much fluoride is present in your drinking water. Again, I don't want to create a lot of scare. I'm not trying to trigger fear here. I do think, however, by way of reading this review, by way of reading the paper that I just referred to a moment ago, again, links to these are going to be provided in the show note captions, that there is extensive evidence that elevated levels of fluoride in drinking water are simply not good for us. Now, that could open a whole discussion of why fluoride is in our drinking water in the first place at all. But leaving that aside, it seems to me that most everybody should know how much fluoride is in their drinking water. And ideally, everybody, yes, everybody is filtering their drinking water. Now, that raises the question of how best to filter drinking water. And that brings an answer of it depends on a couple of things. First of all, how healthy or unhealthy do you know yourself to be? Okay, so if you're somebody who has no health issues, you have plenty of vigor, you're sleeping well at night, you have no autoimmune disease, you're not aware of any health concern, minor or major, well then perhaps you're somebody that doesn't want to filter your water. I would argue that why wouldn't you employ some very low or even zero cost approach to filtering your water? There are going to be other individuals who are suffering particular ailments of brain or body, or both, that absolutely should be filtering their drinking water if they're getting their drinking the water from their tap, because it is pretty well established now that tap water contains a lot of these disinfectant byproducts, as well as, in most cases, exceeding the threshold of fluoride that we know to be healthy for us. How should you filter your tap water? Well, you have everything ranging from the so-called Brita type filters. So these are going to be carbon type filters or other filters that you essentially put over a container or a compartment where you can pour the water over it and it goes into the compartment below. Will those work? Are they sufficient to filter out the disinfectant byproducts? The general answer is yes, provided you change the filters often enough. However, it is not thought, unfortunately, not thought that they filter out sufficient fluoride. So what I highly recommend is, depending on your budget, that you go online and you search for at-home water filters that can filter out fluoride. There are a number of straightforward and inexpensive tools to do that. And here I don't have any relationship to any of the water filters or things that I'm going to mention now. I want to be very clear about that. There's no brand code or affiliation here. I'm simply trying to direct you to resources that will allow you to filter your tap water for it to be more safe for you to consume in a way that meets your budget, with the understanding that people have very different disposable incomes. So the range of costs here is going to be pretty tremendous. I just want to get that out of the way first. There are water filters that you can use repeatedly. So these are what I'll refer to as pitcher filters that are less than $100. Now keep in mind that that's a one-time purchase, except for the replacement of the filters, which fortunately doesn't have to be done too often. So there are different filters. I'll provide a link to one that I found that is, at least by my read, of the lowest possible cost. So this is the so-called clearly filtered water pitcher with affinity filtration. So this is a filter that can adequately remove fluoride, lead, BPAs, glyphosates, hormones, and some of the other harmful things that are contained in most tap water. Again, I do realize that for some people, even an $80 cost is going to be prohibitive, but do realize that what you're doing here is you're purchasing a unit that can be used repeatedly over and over. The reason why it's lower cost than some of the different filtration approaches that I'll talk about in a moment are that you can't really put all the drinking water that you would use, say, for an entire week or for an entire month in one pitcher. You're going to have to repeatedly pour water into the pitcher in order to filter it. Now, as I mentioned before, the range on water filter costs for filters that can adequately remove fluoride and all the other things that you want out of your tap water is immense. In fact, you can find, whole house water filters that are, $2,000 or more. Again, these are going to be filters that are going to be in your garage or in a laundry room that are going to basically pull from the piping system of your house and deliver purified water. Technically, it's not purified, but that's removing these contaminants and fluoride from all the sinks in your house, so you could effectively drink from any or all sinks in your house. That's what explains the higher cost. I think most people are probably not going to have the disposable income or have the opportunity to include one of these whole house filters, although if you do have the means and it's important to you, you could do that. And then there are going to be what I would call intermediate systems, so systems that cost somewhere between $200 and $500. Probably one of the more common ones or popular ones is a so-called Berkey filter system. These are filter systems that, again, remove the things that you want removed from your tap water, and they can do it at higher volumes, and they're typically countertop units. They don't require any plug-in typically, or they only require brief plug-in and electricity. And they're going to filter out many, many liters or tens of liters of water so that you can always have access to that clean filtered water any time of day or night without having to pour over into the pitcher. So I mention these different options because, again, I realize that people have different levels of disposable income. As far as I know, there's no tablet or simple mechanism that can be purchased as a transportable pill that you can just simply throw in water and remove the contaminants. If anyone is aware of one that can adequately remove fluoride and other contaminants, please put in the comment section on YouTube. That'd be the best place so that I and everyone else can see it. But hopefully the mention of the different filtration systems that I mentioned will give you some choices that I would hope would fall within the range that one could potentially afford. An important note about filtration. Just as in our body, there are mechanisms to signal mechanical changes and chemical changes that occur in our gut, in our brain, et cetera, elsewhere. And in general, both mechanical and chemical changes are signaled across the body to invoke different changes, whether or not those are, a response of the immune system or to make us more alert or more asleep, et cetera. So too, filtration capitalizes on mechanical and chemical filtration. What I mean by that is when you run a fluid, water or any other fluid, through a filter, those filters are doing two things. They are physically constraining which molecules can go through by creating pores, that allow certain size molecules to go through and not others. And almost always they contain certain chemicals themselves, right? Those filters have been treated with certain chemicals that neutralize certain other chemicals. Okay. So you may be wondering how, when you filter water, magnesium and calcium could get through, but fluoride doesn't. And that's because these filters have been very cleverly designed in order to neutralize fluoride or to prevent large molecules such as sediment and dirt, which is kind of easy to imagine being filtered, but also to allow certain small molecules like calcium, which is small-ish, or magnesium, which is smallish, to still pass through into our drinking water. And this is wonderful because what it means is that by filtering our water using any of the methods that we talked about before, you're still going to get whatever magnesium and calcium was present in that water while still adequately removing the fluoride and other disinfectant byproducts.